Welcome back to the second part of chapter number 8 of CCNA Cybersecurity Operations with me, Joachim Kärrestad from the University of Skövde. In this part we will talk about access control. We'll talk some access control concepts and we'll discuss AAA a little bit more than we did before. And this is only like 6 slides, so it may be rather quick. And we'll begin with introducing the CIA Triad. So CIA is not only a 3-letter agency, it's also a triad used to describe three key concepts of information security, and those are confidentiality, integrity, and availability. Confidentiality means that only authorized individuals, entities, or processes should be able to access sensitive information. Integrity refers to the protection of data from unauthorized alteration. We should be able to know that the data we receive is the data that was sent. We should know that stored data is not being altered, and so on and so forth. And availability refers to that authorized users must have uninterrupted access to important resources and data. So whatever we are trying to provide should also be available, and that's a fundamental security demand. This triad is sometimes extended with traceability or accountability, basically discussing that you should be able to know what user that did what. So you have some sort of traceability or non-repudiation implemented within your system. So let's switch over to access control. To protect assets, we use access control, and there are some different models for implementing or for using access control, where the first one is mandatory access control. And this basically applies the strictest access control and is typically used in military or mission-critical applications. So the idea here is that we assign security level labels to information and enables users with access based on their security level clearance. So if you're cleared to view top secret documents, you can read documents that are classified as top secret and everything below. Then we have discretionary access control, or DAC, and this allows users to control access to their data as the owner of that data. Discretionary access control may use access control lists or some other methods to specify what users or groups that have access to the information. Then we have non-discretionary access control, and in this case access decisions are based on an individual's roles and responsibilities within the organization. So for instance, a manager will have access to that, a user at this department will have access to that, and so on and so forth. And this is sometimes referred to as role-based access control, or RBAC. Then we have attribute-based access control, or ABAC, and this allows access based on attributes of the object or resource to be accessed. So the user accessing the resource may and environmental factors regarding how the object is accessed, such as the time of the day, may affect whether or not access is granted. So let's end this rather short lecture with revisiting AAA. So AAA is a protocol that provides the needed framework for scalable access security and have 3 components. Authentication, meaning that users and admins have to prove that they are who they say they are, using, for instance, a username, some challenge response protocol, token cards, or other methods. Authorization, which means that after we authenticated the user, we need to use some authorization service that determines what resources the user can access and what operations the user is allowed to perform. The final part is accounting and auditing, and accounting records what the user does and when they do it, including what is accessed, the amount of time the resource is accessed, and so on and so forth. And accounting keeps track of how network resources are used. So we can implement AAA in 2 distinct ways. Either we can have local AAA using some local user password database, or we can have server-based, where we use a central server for authentication. When we use server-based authentication, we can use the Radius or TACAX Plus protocols that we've discussed before. I just included some summary information in this slide. So Radius uses UDP ports 1812, 1813, 1645, and 1646. So that is a typo right here. It combines authentication and authorization and only encrypts the password in package sent. TACX Plus uses TCP port 49. It separates AAA functions and encrypts the entire body of a package. And centralized AAA enable the use of accounting and enable us to log user actions. So I did that in 5 minutes and 20 seconds or so. Until next time, leave comments where you know that they should go, and see you in a little while.